Welcome all. I think we are almost towards the end of the conference. I presume you might have learned a lot of new, interesting things during conference. So, I thought I would also close it with something new, something exciting, something that you probably have maybe hearing it for first time. And if that clicks, maybe you can spend some time over weekend to figure it out as to what exactly the prospect of this particular thing is. We are going to next 30 minutes answer this question: why run MySQL on ARM? So we'll see what are the pros and cons, and should you start running MySQL on ARM. My name is Krunal Bauskar. I have been driving MySQL on ARM initiative. Uh, so Yeah. That's quick intro about me. I've been working in MySQL space for over a decade now. Currently, I'm working with Huawei as part of the open source DB group. In past, I've worked with Percona as PXE product lead, at Oracle as DB developer, at Yahoo Labs as big data research engineers, and a whole lot of other things. I've been driving this MySQL on ARM initiative, which covers all kind of MySQL databases. That's like MySQL, MariaDB, and Percona, and also, of course, the ecosystem tools. I normally speak at Percona and MariaDB conference, so this is first time, and thanks to organizer for getting a chance to talk at open source OSI 2020 session. I do a blog. That's my blog link. Okay, so let's talk about today's agenda. So we are going to quickly look at the ARM ecosystem. Then we will see the state of MySQL on ARM. Then we will try to come back to our original question as to why run MySQL on ARM. And then we will talk about what are future work and directions around it. So ARM ecosystem. I'm sure almost all of us have heard ARM. I think likely most of us have heard ARM from processor perspective. Most of our phones these days have ARM based processors. So I think cell phones and network equipment are very common where ARM get used, thanks to the perform in terms of the wattage or power consumption it uses. If you stretch it further, you would discover that it is also used in housing appliances and IoT devices. In fact, Alexa also has an ARM based processor. So that's the second other vertical. If you further stretch it, you would discover that automobiles, especially these days, self-driving cars, a lot of other electronics are there in cars. They do use ARM-based processors. Defense equipment, space equipment, they do use ARM-based processors. Something which is new, as in new in that something which was there, but that started picking up pace lately, is high performance computing. So ARM started, more and more people started using ARM for high performance computing. So what exactly has changed, right? So of course, ARM, all we knew about is it is very good in terms of performance per watt. It is very low at power consumption, and that way it helps save the cost, and it can add more cores. Typical high performance computing softwares like databases, application server, big data applications, load balancers, all these things started, running things on ARM. But I think it was fueled by lately in last couple of years. If you see, the ARM instances started getting offered through cloud, which was kind of a gap. If I wanted to boot a strong ARM instance, there was no option. Most of our laptops and machines were Intel x86 based. So, but now that gap is getting filled. So, for example, Huawei Cloud has ARM instances through its high silicon Kunpeng 920. Amazon has its ARM instances through Amazon Graviton 2. Ampere Ultra, this is a startup. If you have not heard it before, Oracle Cloud is planning to offer ARM instances using Ampere Ultra. Already, Packet.com offer instances based on Ampere Ultra. So that, I think that was the game changer with cloud instances making available. User developers could quickly boot it, run it, and start running their software. Beyond that, beyond the hardware aspect, even the OS providers in last few years, almost all OS providers now has a port for ARM. multiple projects now, whether it's big data. Lately Hadoop started supporting ARM databases. MySQL already have support for ARM. MariaDB has support. Postgres has support for ARM. Load balancers, application servers, all of them started to support ARM. Now the USP, of course, is ARM cloud instance is has a potential to generate 30% cost saving, and I think that is the major push why user or developers have started looking at ARM. Uh, the other aspect is also that data generating devices. We spoke about some of the data generating devices like IoT, cars, and all. All of them are on ARM. So having data processing devices even on ARM makes the stack complete. So everything is integrated onto the ARM ecosystem. So I think that was has been the reason why ARM has started getting so much of traction lately. But then this is often a question which I get. ARM is there for quite some time. Why is it taking still longer for software to get ported to ARM? And there are challenges. Porting to ARM from x86 is not like a one night job kind of thing. So ARM is a weaker memory model, which effectively means you have to tune your code to use proper memory barriers. Also, beyond that, ARM has is a completely different processor, so you need to retune some of your timers, spin loops, these kind of aspects. ARM is all about more cores, right? So if you are going to have more cores, then your software should able to make use of them effectively. So these days, if you look at it, most of our whenever we think of some kind of data structure, we think of it from a straddled perspective. How does it work in lock free fashion and all? So all those aspect needs to be considered. ARM do inherently offer ACLE, which is hardware instructions. Intel offered it through SSE. If you have heard about that, SSE, ARM offered it through ACLE. ARM also has its own parallelization support in form of Neon LSC. So you should actually, harvest those aspects. And then there is, of course, cache line differences, branching differences, pipeline differences. So all these things are there. So when you port a software, see, well, the software will work on ARM. That's not a problem. But making sure that it is optimal on ARM is what we are trying to address. So with that quick, intro about ARM ecosystem, let's talk about the state of MySQL on ARM. So, typically when any user tend to move on to some new DB setup or DB environment, they do consider these four aspects before they move on. Whether the new DB or whatever you are looking at is feature set, what kind of feature set is there? Am I going to lose on some features? Performance aspect, ecosystem aspect, and community support. So let's look at one of them one by one. How is MySQL doing on them? So MySQL, as you know, has started offering or releasing packages for ARM starting with 8.x. So the packages comes from MySQL official repo. So they officially support it. Now all features are supported. We are not aware of any feature which is marked even beta or not supported for ARM. So all the features which you see in MySQL, if they are supported on x86, they are supported on ARM. The way I look at it is MySQL write a representative test case for all the features they work on or they release. And if you want to test it, you can just run that test suite completely also and see if anything is failing or reported to be not supported. Now, even beyond the mainline storage engine which MySQL has, if you are trying to go it for a master slave kind of application or a HA kind of thing, even there, bin log replication, group replications are supported on ARM2. And correctness, so MySQL, since it's officially supported, couple of I think couple of bugs got reported on ARM, and MySQL did fix them with the same priority like x86. So in that sense, we can say MySQL on ARM is feature complete. So you are not going to lose on any feature if you think of moving to ARM. Okay, so the next is performance, right? So I think that has been the driving direction why user want to think of moving to ARM. And let me tell you, well, of course, we will going to see a lot more performance number in our second part, but MySQL has been fixing performance issues lately, a lot of them, and they have been considering or making sure that they have considered this aspect that the new generation processors, including ARM, of course, Intel also has multi-NUMA or more core counts, but mainly for ARM has more core counts. So MySQL has been designing their fixes so that they use shredded counters and shredded locks and all these things. So they are making sure that the code is also compatible and can harvest the increasing core count aspect. While there is no major efforts, at least we are not aware of any major efforts done by MySQL only to optimize things on ARM. But lately, with upcoming release, hopefully with 8.0.22 or post that, we could see that there are few patches that MySQL has accepted, and that seems to be having a revive interest on MySQL side to start optimizing things for ARM. If you look at the community till now has contributed 30 plus patches to MySQL on varied direction, checksum optimization, 64-bit, NUMA aware counters or code base, memory barriers, spin loop timer, branching, cache line, atomics, something which we just talked about. So almost on all aspect, MySQL community has contributed to patches to MySQL. So already we'll see how MySQL is performing even without these patches, because most of these patches are yet to get accepted. But even now it is already performing way better, and once these patches get accepted, I'm sure it's going to just fly faster and faster. Backup, sorry, ecosystem. So of course, when you adopt a software, you also need to think of an ecosystem, and which effectively means all the supporting tools. So MySQL, of course, support the server, but along with server, it does support MySQL router official packages on ARM. That's load balancer category. MySQL shell, which is a smart shell these days, if you have used it. MySQL connectors, and MySQL InnoDB cluster, which is in fact inherent to the server. So MySQL do support some of the ecosystem component. Some components which MySQL, I would not say not support, but they have an enterprise version. And since we are all open source, so if you look at open source tool, for example, for backup, you can use Percona Extra Backup on ARM. It works. We have blogged about it. Monitoring, you can use PMM, which is another product from Percona for monitoring. It too works. Toolkits, you can use Percona toolkits. In sense, ecosystem is there. At least we have representational product. Of course, the ecosystem needs to grow further, and we know some vendors from the MySQL ecosystem who are working on porting their software to ARM. So the ecosystem is just going to grow further. Of course, already it is kind of I would say the loop is complete, but it is just going to get stronger and stronger. But beyond that, of course, there are missing gaps. Official Docker images for ARM64, if MySQL could make them available, that would be great. There are a lot of other supporting ecosystem tool, for example, shredding, migration tools, other monitoring and backup tools. So that would just keep on, adding to the ecosystem. And community support. So of course, since MySQL support it officially, you can get a consultancy services for them on ARM too. But MySQL on ARM community is growing. So community has been mainly helping in testing new features, performance aspect, tools. We saw they contributed good amount of community, contributed good amount of patches, and it came from varied organizations. So a lot of community people from varied organizations are getting interested. Ecosystem completions, we are trying to tend towards interoperability of the tools or different setup, whether it's cloud, on-prem, Kubernetes, and all. So the state of MySQL, as in terms of, if you look at from the point perspective, we could safely say that almost all the aspects are being taken care of. Okay, some of them are going to grow, some of them are already taken care of, like feature set is already, performance we'll see, ecosystem and community support. So we can say that MySQL on ARM is ready, and people can start adopting to it and start running it experimenting it, and then eventually run it into production and all. Okay, so with that, let's talk about our original question. But why run MySQL on ARM? So that's all good thing, right? We spoke about a lot of good things, but our original questions still remain. So, before we get into the real things, I wanted to actually, introduce to you CPM. So the reason why is like ARM USP is more cores at lesser cost. So to exploit this, you needed a model so that you can actually be fair and able to compare ARM with x86. So this is just an example. If you This is like with three different cloud providers: Huawei, AWS, and Packet.com. And if you tend to boot a same flavor of ARM instance and x86 instance, you would discover that ARM instance or booting ARM instance is always a cheaper thing. And of course the price could vary, but we can easily say that booting an ARM instance is roughly 30%. We can say that roughly 30% cheaper than booting x86 same flavor of instance. So then the typical way what we can do is we can run MySQL on ARM and MySQL on x86 and see if MySQL on ARM perform same like x86. We can claim we got 30% cost saving. But the problem with that approach is there are CPU frequency differences. The base CPU frequency of ARMs is like ARM is about not that super fast processor, but more number of cores. So if so, like horizontal scaling versus vertical scaling. Beyond that, Intel also has turbo modes. There are CPU generation differences. Finding a CPU exactly of the same generation for ARM and x86 is difficult. x86 has physical cores versus HT core, that's hyper threading technology. NUMA arrangement could be different. Memory differences are there. There are scheduler differences. What I heard is with kernel 5.x onwards, there has been improvement in terms of how how the NUMA thing is handled. Okay, so if you come back to the things, right? So we relook at the problem, and how we look at it is if we keep the cost constant and we try to look out for ARM resources, and if we can see that if we can get more performance from ARM, then it effectively turns out to be more TPS per USD. If I state it the other way around, if I have X USD to be spent and I could get M ARM resources and I could get N x86 resources where M is greater than N. So can I use that extra resources of ARM that I got to get more performance because my cost is same? If ARM extra resources can give me better performance, my TPS per USD is going to be higher. So if I put it in formal definition, given the on-par cost of both the resources, can we exploit the ARM variant to its fullest benefit and get better performance when compared to x86? So that's the idea. If we want, let's look at some data point to make it further easy to understand. So I've taken an example from Huawei Cloud. Let's say I have 3500 USD to be spent, and for that I could get a 12 vCPU 48 GB machine or VM of x86, and I could get 24 vCPU. Note the difference, right? We are almost getting double the vCPUs, and the same memory 48 GB for the almost same, roughly the same cost. So it effectively means for the same cost, you are going to get double the number of cores or double the computing power approximately, because frequency differences are there. But let's say double the computing power if you move on to ARM, right? And this difference is with VM, and with bare metal the difference is even wider. It ranges anywhere between 2.5 to 5x or even further, as in what I have is based on the numbers I have access to. So let's now use this model. We just talked about the CPM model and see how MySQL performs on ARM and on x86. So we have used sysbench testing, a pretty standard. We have tested it with varied things, with CPU bound, IO bound workloads, all kind of sysbench, sub test cases, point select, read workload, read write workload, update workload, and all. Machine configuration, so this is bare metal. So as I said, bare metal, the difference increases. So for the cost, I could get 28 HT core, that is hyper threaded core, for x86, and 192 GB of memory. And for the same cost, I could get 64 cores of ARM, that is more than double. Okay, and same 192 GB of memory. And storage, of course, is same for both of them. So if you look at it, what we did is we kept all the configuration constant except and even the cost constant, And what we tried selecting the flavors, and what we got was we almost got more than double. I think it's 2.25 roughly, in terms of factor, so of more cores of ARMs versus x86. Okay, so we got more cores, remaining things constant, but let's see whether these core helps. Okay, so this is the chart, right? So what we have done is we have run an experiment using Sysbench, and this is a uniform distribution. So Sysbench actually have multiple distributions. So one is uniform, which effectively means almost all data is touched, and which generates more load but lesser contention. So with this is CPU bound, so all data is in memory, and the blue line represent ARM and the red line represent x86. So you could see blue line or ARM continue to score till lower scalability x86 scores, but once it crosses the scalability point, you could see that ARM continue to score, and in fact with higher scalability the difference is almost double or start to grow. And in fact with update index or update non-index, like read write use cases, you could see that the difference is even for lower scalability ARM is almost on par with x86, and start scaling way better with higher scalability. So we talked about CPU bound. So we saw ARM scales. What about IO bound? So most sometime users, and of course, I think a lot of our use case user has IO bound workload. So not complete data fits into the memory. So how does ARM does it scale there? And yes, it does scale there. You could see the same pattern is observed. ARM is continue to scale way better. In fact, here even for lower scalability, ARM is scaling. So ARM scores even on IO bound workload. Now let me talk about Ziphian pattern. So this, the reason I have included this also is Ziphian is like it only updates or touches a part of the data, but it represents a more contention. So sometime uniform represents less contention because it touch all the data, but Ziphian touches only part of the data, so less more contention. So let's see what are the result here like. So again, as you could see, ARM has continued to score, right, almost on all front. And see, the important point is ARM is scaling on all, whether it's a read workload, read write workload, or write workload in form of update index or update non-index. And this is Ziphian IO bound. Of course, again, it is scaling well. So ARM maintains the lead. Now, if you go further and if you think beyond Sysbench, if you are running like TPCC kind of, or you have TPCC kind of workloads, or your workload represented by TPCC, there too you could see ARM continue to score. And in fact, with higher scalability, you could see the ARM is almost double the throughput compared to x86. So the idea is very simple. So idea is very simple, right? So ARM always scores in all cases. But the real question is, why run MySQL on ARM? So all this is good, right? But what about what is the motivation for end user like me? Why should I run thing on ARM? So let's take a simple example, a data point I fetched from our existing graph. So I've used 1024 update index use case. You could see the TPS of ARM, of course, is better than x86. But if I, since the cost is constant for machine, if I calculate TPS per USD, then you could see that I'm getting 42% more TPS per USD compared to x86. So what it means is more TPS at same cost. So I'm going to get more throughput for the same cost. The only thing I change is the processor. Now, if I look at other way around, right? So this is a common problem all of us face, right? So I need to scale the DB for more performance, and I question how do I do it. The problem or the solution is simple, right? You can need to scale MySQL. You can go get better or larger hardware or VM, whatever it is, but you have to shell extra cost. Okay, that's how typically we have been doing. We start seeing problems, and then we probably just go and boot up more resources on cloud, and then we start to scale. But what if I tell you that you can keep your cost constant? You can use your same database, no change in database, same environment, nothing changes, but you just switch to ARM and you just get more performance, something which we just saw, right? So that isn't that a cool solution? keeping a cost constant. And these days, with the pandemic going on and all, people or almost all organization has become cost conscious. And if you are getting a solution where you could still scale, still meets your throughput, because everyone is now moving online, so I can still go ahead and keep my cost constant, but I can still scale better. Isn't that a wonderful solution? So I think that's the USP of why you should think of moving to ARM. So ARM not only help you generate cost saving, it also is energy saving. So it's a Go Green, it support Go Green initiative that way. Now, not only with a single node, if you have like a multi-node, as in master slave kind of thing, maybe you have to boot n slaves, or let's say in this case I've showed 4 slaves booted. But since the throughput with ARM is higher, then you can easily say that, well, I will have to boot one lesser slave, because I am able to maintain my throughput and service the same number of users, and that effectively turns out to be a lesser cost for same throughput. So the key idea is this: any workload, we saw graphs for CPU and IO bound. Any pattern, we saw read only, read writes. Any use case, we saw contention, non-contention. Any setup, whether it's single node, multi-node, ARM always score. So I think that is the wonderful thing that MySQL and ARM could help you be the next solution for your next scalability. So with that, quick thing about future work and directions. See, well, community is growing. Community continue to push for more performance improvement. The way I said is like, this is not even, MySQL has not even started optimizing it. There are 30 plus patches which are waiting from community. Imagine what is going to happen if once all these patches get integrated, MySQL also invest their time optimizing it. ARM is going to break all these small crisscross you might have seen in the graph. That will also will be left out. We expect Oracle MySQL to support more distro, Docker images, and missing ecosystem components. We are optimistic that MySQL in upcoming days will continue to accept more contribution like it did in the recent time frame. And as a community, we continue to explore different use case, fill the gaps, explore or understand what is missing, and see how what components could be interoperability and all these things. So we are trying to push that. So you can contribute, you can follow. If you are not aware, MySQL Slack, that's official Slack MySQL has a dedicated MySQL on ARM channel. You can subscribe to it, join it. You can read more about MySQL on ARM on my blog. You can write to me also. Email me, it's fine. Twitter handle is there, and LinkedIn profile is also there. So if you have any, if you have a ecosystem tool which is part of MySQL ecosystem, and you want to port it to ARM, you are interested in getting it ported, you can of course reach to me. I can also help you, direct you, or do something. And of course, go ahead, join the MySQL on ARM. It is the next big thing. I see it's the next big thing coming up into the MySQL ecosystem. So thanks for attending, and happy MySQLing on ARM.